Alrighty. Whenever you're ready, Hayden.
All right. Hello, everybody. My name is Hayden. Um, our goal for this project was to make a chess engine that is like a non-traditional chess engine. It's trained on puzzles and it's also trained on stockfish evals. So the idea is sort of to train the chess engine as a way humans would learn chess, as opposed to constantly throwing or constantly making it play games against itself. Reinforcement learning, which is how most chess engines are trained at the moment. So for this project, we wanted to use a CNN model, and we will get into how we did that in the next slide. So we had a lot of data source attempts. As mentioned previously, the first idea was to train the chess engine with puzzles. Lichess has a massive database of puzzles that you can download from, and originally we tried to use that, so that those were JSON-L files, and we parsed the Fen data and the best move data, and we tried to use that to train our baseline model. The next slide will show us how we did that. So here, this is what most of our data looked like for the baseline. You'll have this Fen position, which basically just represents a unique board position for chess. And then you'll have these W's, or you'll have blacks, which represent whose turn it is to play. And then after that, you'll have a KQ and like a capital KQ and a lowercase KQ, which tells you if castling is allowed for white and black respectively, and on the king and queen side respectively. So then after this, these are the best moves that we would go on to try and train our baseline model with. This is actually not our final cleaned product, because for the baseline, we only trained it with the first best move. Okay. And this is going to be how we're going to extract data for the final, but the next slide should show us how we do it for the baseline. We'll come back to this slide. Okay, so for the baseline, what we did is we took that Fen position and we threw it into a matrix where each piece was assigned a value. Black was assigned a negative value and white was assigned a positive value. On top of that, we converted the moves to numbers. So that's what you see, like the Y train as 3, 6, 3, 5, 4, 4, 3, 5. We would go on to later dump every move that wasn't the first move. And then we would also have these legal moves. The legal moves proved to be a little problematic because they weren't standardized for the CNN. Like you could have one chess position that has, say, 30 possible moves, and one chess position that has 2 possible moves if the king is in check or whatever. So we had to zero pad our legal moves up into 30, I believe it was.
Yep.
All right, so this is the data processing in the CNN. So, yep, this is mostly just what I discussed for our baseline model. This approach would go on to fail. It performed pretty bad. I'm guessing there's a lot of reasons, but yeah. So the next approach will be about semi-pod loss. So we mostly just explained the baseline, so I don't know if we need to go into this too much, and we're running a little low on time, so I guess we should move on.
Okay. There's our baseline model, flatten the tensor by 8x8, goes through 2 CNN layers to a ReLU activation function, and then finally flattens the output, which includes the best possible moves, which the model is trained on. There's sometimes multiple best possible moves that are tied, quote unquote. So that's why it's a 64 by 64. And here's our data then with our baseline model. It looks very, very good in testing and validation. But as we actually played against real people or even Stockfish AI, which is like the big open source AI, as explained previously, it performed actually pretty poorly. Um, our initial win-loss was 3-6-1, which is somewhat accurate to our data in terms of wins, but not so much for draws. Our draws were much higher in our testing and validation, and our loss was much, much lower in testing and validation than in reality. Early model results were disappearing. We couldn't really figure out why. I think at the end of the day, after more discussion, I think we improperly used the CNN at first to input our data, and it just was neglecting some of the opposing moves. Because there was a lot of blunders, very obvious blunders that a regular person would obviously be able to see, and the machine was not picking that up. And then it's our final model for loss over time, training and validation. Looks a lot better. Labeled versus unlabeled. So at first we were using a lot of label data, and eventually we realized we should probably use unlabeled data for it to figure out better how to play against Stockfish and other players and be able to endure longer games versus the chess puzzles were short games that had 1 to 6 moves. Instead, these are longer games, and by using unlabeled data, data points for training and testing, we were able to better train the model to win more games against real people and Stockfish. And then here's a little bit about Cinnapon loss. It's basically just talking about how like the score that Stockfish gives you creates then an advantage for either the white or black side, positive for white, negative for black. Then here's our high level of the final model. We have a 3D convolutional layer. We have 14 8x8 matrices, and then we have within there it is like pawn, rook, bishop, all those layers for white and black, and then we also have a matrix of how many potential like legal moves that we can do. Then we flatten ReLU function, sigmoid function, and then return the board and output to the screen. And here's our model data. It's much more realistic, a lot more draws, or a little bit less draws, sorry, a little more losses, and approximately about the same win percentage for training and validation. For validation, we use the Minimax to evaluate how our model performs during baseline is 3-6-1, as previously mentioned. And then lastly, here's a sample game with a highly skilled human player. AI plays black. Sometimes it took, you can see on the bottom of each screenshot, there are varying times. Sometimes it took a minute or 30 seconds to play. Other times it took several minutes to play against a high level player, as this model looks 10 moves ahead. So it takes quite a bit of time to find the best move for 10 moves ahead, especially if you're playing against a high level player. Then here's some more of the screenshots. And lastly, sources. Here's all the sources that we used, ranging from when we first were researching to try to figure out exactly what we wanted to do with some reinforcement stuff. Wasn't too much on CNNs, as reinforcement has been kind of the commonplace thing to do. But this is where we drew a lot of our inspiration from, as well as how we used lead chess initially, and whatnot. I think that is all. Thank you for
Well, I
watching the
think that was
presentation.